My name is Dan with High Yield Medical Student Stats, and today I'm going to show you how to do an independent samples t-test, which is usually used to compare scale numeric values between two groups. And one important thing to note is that these values have to be in a normal distribution. So an example of when is a good time to use a t-test is when you're comparing means for two different groups, such as test scores between two classes of students, or in our scenario, comparing pain scores between two groups of patients receiving different treatments. In this example, we have patients in two different procedure groups shown here, 1 and 2, with their pain scores shown to the right. And we're going to compare the mean pain scores between these two groups using an independent samples t-test. First, we should go into the variable view and make sure our variables are in the proper format. The grouping variable in the scenario procedure is also known as the independent variable, and that should be a nominal value. And the dependent variable, pain, should be a scale value. Next, we go to Analyze, click on Compare Means, and go to the Independent Samples t-test. Here, the test variable would be the dependent variable in the scenario pain, and the grouping variable would be the procedures, the independent variable. We can take a look at the options, which we usually leave at the default confidence interval percentage of 95%, and then we do not need to bootstrap in this scenario. We will then be prompted to define the groups, and it's simply group 1 is 1 and group 2 is 2. Next, we get the outcome, and in this outcome we see three different tables. Table 1 shows the group statistics, which shows the number of patients shown as n. The mean in the scenario group 1 has a mean of 6.9 and group 2 has a mean of 4.1, and the standard deviation for both, as well as the standard error mean. The second table shows Levine's test for assessment here, which assesses the variance within each group and sees whether it's different or not. The sig column represents the p-value of this test, and if it is less than 0.05, we cannot use an independent samples t-test as it is only used for normal distributions. In this scenario, it's not significant, so we can proceed. Next, we see the results of our t-test right over here. You can see the p-values for both our one- and two-tailed hypotheses. Also, there's the mean difference between the two groups, which for us is 2.8, with the standard error and the confidence intervals shown on the right. And in this table, you see that the p-value is less than 0.05 for both, which means there is a significant difference. The third table looks at the effect size of this relationship. And the effect size basically determines the strength of correlation. With the higher the number, the stronger the relationship. Cohen's d is most commonly used for effect size, with a d-value of 0.2 signifying a weak effect, d-value of 0.5 being a moderate effect, and a d-value of 0.8 signifying a strong effect. So for our example, our effect size is 1.76, signifying a strong effect. Thank you all so much for taking the time to see the video, and if you have any more questions, please feel free to leave a comment below. And we will be doing more videos in the future on the different tests that can be done on SPSS.